Josh, if engineering were a giant metallic ball of death and destruction, you would be a two-headed bear bot in Kevlar whitey-tighties.
Yes, welcome to Engineer vs. Designer.
Podcast.
We're product designers, engineers, and anyone who would like to open source the entire manufacturing industry. My name is Josh, mechanical engineer of SolidSmack.com.
My name is Adam, industrial designer of CADJunkie.com. Each week's show is emulsified into three equally gooey halves. This week we're talking open hardware initiatives and super rockin' construction systems. First, we get a good old fact smack courtesy of SolidSmack.com.
Yep, followed by design process tips, tricks, and insight compliments of CADJunkie.com.
And today we've grabbed one of our favorite projects to date from Kickstarter, OpenBeam, the open source construction system.
Fully funded.
And speak with the creator, Terence Tam of Seattle, Washington.
Terence, hello. If you could build a desktop trebuchet capable of launching you through the wall, made from the material of your choosing, would that wall be made of A, spaghetti, or B, a nest of spiders that could give you superhuman powers?
So if you can guarantee me that I can fly and see through things afterwards, I'd say bring the spiders on.
Right on.
Thanks, Terence. Sit tight. We'll be hearing more from you as the show goes on. Speaking of human ballistics, Josh Mings of SolidSmack.com, fire us through the flaming hoops of ignorance with the human circus cannon of knowledge.
Yes.
What have you got for us this week?
All right, this week's SolidSmack Fact Smack is brought to you by Fortis 3D Production Systems. From your office to the factory floor, Fortis offers efficient digital manufacturing solutions for your business. Rock it at Fortis.com. Now, in a moment, we'll be talking about the newest, coolest construction system you can possibly fathom.
Can't even imagine.
Where did the idea of simple sets of reusable rods and hardware start?
Where did it start, Josh?
Probably ancient Rome, but we're going with A.C. Gilbert's creation of, yes, the Erector set.
Mr. Gilbert got a Kickstarter of his own when his father lent him $5,000.
Which was about 23 grand in 1910.
To start a magic shop business, of all things.
The magic product led to financial success in 1913.
When the Erector set was born.
Yes, introduced at the New York Toy Fair, it was an instant success. 9 different sets were available from 50 cents to 25 bucks, with all the models and instructions designed by Gilbert himself.
Erector sets included pulleys, gears, and a number of 1-inch wide steel strips, with the edges folded over, permitting 4 strips to be assembled using 2 screws to create a strong square box girder. And the rest is history.
Wow, more than toys, the Erector set became one of the most effective tools for learning scientific and engineering principles. And today, we have a guest with us who has created a construction system of his own, Terence Tam, creator of the OpenBeam construction system. All right, Terence, what is the 10-second elevator pitch for OpenBeam?
So OpenBeam is a low-cost, open-sourced miniature version of a T-slot construction system like 8020. And to keep the cost to a minimum, we decided to use standard M3 nuts, and we injection molded the joining plates out of glass reinforced nylon.
Wow. Now, what's different about your system from a conventional T-slot construction system?
So the theory is the same. You have an aluminum profile with that's designed to capture a nut on all 4 sides, and you can slide the nut up and down and tighten the screw wherever you want, right? But what is different about OpenBeam is instead of forcing you to go with a proprietary nut that is, by the way, way overpriced, the slot is designed to fit a standard M3 nut that conforms to the DIN standard, or a M3 cap head screw. So you can put a threaded stud or a nut anywhere on the system, and that drops the price significantly. Okay, the other thing that's different is we're using a glass-filled nylon, an engineering resin, to do the joining plates out of. And so we can get some really interesting geometry on the plate to make it stiffer while at the same time lowering the cost.
That's great. What convinced you that open sourcing this construction system would be a successful business?
Well, so when I first started, I did some patent research, and it turns out that almost all the patents from T-slot systems, date back, there's references from like 1950s and earlier. So the good news is, I'm not, but these patents are now in public domain. But the bad news also is I really can't protect it, right? So even if I were to get a design patent, it wouldn't, it's a lot of money to go after a patent infringement. And to be honest, I'm a small guy. I'm not going to be able to do that. So I might as well open source it to speed the adaptation. And at the same time, it gives me a lot of good publicity for the product.
Yeah.
Uh-huh.
And I think it's worked out really well for me.
Now, I mean, and really quickly, you started out with Kickstarter, which, we've been talking about quite a bit on this show lately, actually. A lot of cool stuff happening there. Why did you think that Kickstarter was the right place for you to get started?
Well, to be honest, I think this is like the only viable route is to crowdfund something like this. I mean, if you think about the definition of an investor, right? He or she is somebody that's rich who wants to get richer by getting a return on investment, right? So from their standpoint, you're asking them to open their wallet up to back a project that cannot be protected from an intellectual property standpoint. And not only that, you're going to be giving it away for free as an open source project. So if I were to take investment money, I'm going to be under pressure to design it to be as proprietary as possible. Basically, the only way for the investor to get investment on return is for me to screw my customers. And that's not a direction I'm interested in going, and that's not what OpenBeam is about. So I think Kickstarter is, the only real route to do something like this.
Josh, I need you to stop chewing on that tea slot. Stop it. It's bad for you. That is bad for you.
Tasty. Love it. We'll be back. Adam O'Hearn of CADJunkie.com. The smelting pots of insight beckons.
Oh, yes, it does.
Feed us your massive medley of molten knowledge.
Yes.
What's on your mind?
This week's CAD Junkie Q&A is brought to you by Fortis 3D Production Systems. Fortis Systems produce accurate, durable prototypes and production-grade parts using high-performance thermoplastics. See it all at Fortis.com, or even talk to our special guest, Terence Tam, who apparently did a lot of his prototyping for the OpenBeam slot system using Fortis products.
Nice!
So, I mean, you had this idea for a T-slot system that would be open source. How did the design process start for that? When you had the idea, how did you bring that into reality?
So it's really funny, and this goes on to demonstrate how powerful a CAD system like SolidWorks is. All the design work was done in 2 nights in a hotel room. I was actually on vacation with a very understanding girlfriend. That was
Well, yeah. I was gonna say you're on vacation with your girlfriend, and for some reason working in SolidWorks on a T-slot system. I'm not sure. I'm not sure if that's what she had in mind when she put this together.
She went to bed. I mean, I was multitasking, and like I said, I have a really understanding girlfriend. But no, I was able to come up with the design really quickly. I was able to run the numbers on the cross-section area and the density of the beam, which drives the price of the aluminum extrusion. Right? It's how heavy is this stuff per meter? That tells you roughly what the price is going to be. I was able to do that and get drawings out and get a quote back pretty quickly to establish that this has a business potential to it. So once I have the CAD data, once I have the design done, the beams are done on an SLA machine. The brackets were done on a FDM machine, actually a Fortis. We ran the parts at my injection motor, put it together, made sure everything fit, painted the beams silver, and shot the Kickstarter video.
So during the process, you went through you used a lot of different softwares. You talked about doing the rapid prototyping. Were there a lot of challenges that you had to overcome in completing the project and getting the first prototypes made?
Well, so the biggest challenge is minding the BOM cost here. And I took some really unique routes to get around that. So not only am I cost sensitive, I'm also NRE sensitive here because I'm funding everything for Kickstarter. So I'm not going to, I didn't expect at least to have $100,000 in the bank to be doing this project with. So anybody that's looking at a project, the first thing they say is, well, why the heck do you go with injection molding? It's really expensive to do. And that would have been true if I had built a mold for each of the brackets. But the secret is I can actually stuff a lot of geometry into a single tool. So I pay for the mold base once, and I have a switch gate in the tool to select which cavity that I'm running. Um, and by doing this, I can spread the cost of that injection mold across the 5 or 6 parts that I have in the mold. And it also frees me from the two-dimensional constraint of going the route of laser cutting the brackets out of aluminum. So now I can add complicated three-dimensional shapes such as the shaft clamps, the bearing mounts, which no other extruded aluminum system at this size and price range offers as an accessory, and I can do that out of the gate at launch.
Fantastic. Well,
and we'll be right back.
That's a lot better than being attacked by cats with.
I hate cats.
Battle axes.
I hate cats, especially the ones with battle axes for paws, paw arms, arm paws.
Paw axes. battle paws with axes.
Thundercats, ho! All right. And welcome back. Today we have the great pleasure to speak with Terence Tam. Terence is a mechanical engineer from Seattle, Washington, who has worked on everything from touchscreen interfaces to medical devices.
We wanted to have Terence on the show because
he's a solid smack reader. That's why.
Yeah, there is that. But then there is a little bit more than that. He also just successfully funded his first Kickstarter campaign and actually raised 3 times as much money as he even needed. I'm convinced that this project is going to save the world from total annihilation. So, Terence, what inspired you to get started with engineering in the first place, early in your career?
So, my dad really deserves a lot of thanks on this one, and not just for not giving me up for adoption when I took apart his first scientific calculator. My dad's an engineer, and and he was actually a hacker before that term became popular. I mean, the dude built the first solid-state drive in the world, probably from core memory in the 1970s. And so when I was I got to solder things and help him stick resistors into boards, and he's always really patient with explaining to me how things work. And I just went from there.
Wow. Gotta love that.
That's fantastic. Do you think that has an influence on you as a maker now, as you move into projects like this on Kickstarter? You think that kind of growing up in a hacker centric environment is a part of that experience?
Absolutely, yeah. Because we as a family, we've always taken pride in making things do things that they're not designed to do. so I think that's the definition of a hacker spirit right there, right?
So there's definitely a DIY prevalence on Kickstarter in general. You have a lot of people who are not traditionally trained engineers or designers, but who have an idea and want to make it happen. You, on the other hand, are talking about doing some pretty sophisticated engineering in terms of developing efficient tooling to make your injection molded parts efficiently and cheaply. Are you at all connected to the Seattle maker scene, or are you more interested in traditional engineering and just using Kickstarter as a platform for that?
So, I'm an engineer by training, and my day job's an engineer. But I also am pretty well connected in the Seattle maker scene. I actually set aside time every week to go hang out at Matrix Create Space or one of the hacker spaces around here. It's good in 2 ways. It's giving back to the community, but it's also there's a lot of creative people from different backgrounds hanging out at those places. So when you trade ideas, you get you become better yourself as an engineer.
Yeah, so you've obviously inspired some people with this project. I mean, it's crazy. You've achieved 300% funding very fast. Do you think this solves a deeper frustration for people that's sort of setting the stage for more open hardware initiatives?
Yeah, so I think traditionally you don't see a lot of mechanical engineers involved in open source hardware. And the reason for that is when you think back to where open source hardware comes from, it comes from open source software. When you're doing open source software, as a software engineer, your cost out of your pocket is your computer and the development tools that you use, and then you're tossing your time in, right? And your time is worth something too, but the financial investment is pretty low. Then you look at open source electronics, and now you have to pay for the circuit boards. That's maybe a couple $100 at the board house. You have to pay for parts, and then with a soldering iron, you can build your first prototypes. But no mechanical engineer out there is going to spend thousands of or tens of thousands of his own dollars on injection molding or spinning up tooling for a product.
Yeah.
And what Kickstarter does is it's a game changer in the sense that it allows you to do that by crowdsourcing. If I were to look at my funding report, I think 80% of my money came in the form of $300 pledges or below.
And so what are people who are pledging this money as a pre-order, I assume? What are these people telling you they're going to do with this product once they have it?
So I've been seeing some pretty interesting project ideas. There's a guy in Australia that's building a telescope, some sort of Smithsonian Trust telescope. There's a gentleman in Spain doing some hologram rigs. And then I think there's
a hologram rig?
Yeah.
How do you build a hologram rig?
I don't know. I'm going to have to email him and find out. See if I can blog about it.
That is great.
Then there's a guy building his own 3D scanner in Australia. A bunch of guys building 3D printers. So that's cool. But yeah, I'm definitely seeing some pretty interesting applications coming out of this.
We talked about the Kickstarter campaign a little bit earlier. What are some aspects you learned about in going through this for a successful Kickstarter campaign?
So there's two really important sides, to running a good Kickstarter campaign that I think a lot of people neglect. One is the project management aspect, right? And what I mean by that is you need to know your BOM cost. You need to know, you're not ordering something, bill of material costs. I'm sorry, yeah. So you don't want to be selling, you don't want to promise a product at $200 a piece and find out that widget actually costs you $220 to build, right? So now suddenly you have an order for 2,000 of these guys, and you're owing $20 a pop on that, and that's going to suck. You don't want to order something that takes a 6-week lead time 2 weeks before you need it. Things are going to be late if you do that all the time, right? And on top of that, you need, and the second point is you need to manage your customer's expectation. So, if you think about the guys that are backing you on Kickstarter, these guys are enabling your dream, right? You're just going to be someone with a dream unless they open their wallets up to you, and you need to take care of them. And don't overpromise. You want to underpromise and overdeliver. You need to keep the communications line open with them. And an example that I do on OpenBeam is one of the things I request from all my vendors is I request that they give me things that I can blog about. So when my tooling guy in China is, building in Hong Kong is building the injection mold, I get pictures of it, I get CAD renderings of it, and I go around and put it on blog.openbeamusa.com so that people can see progress. The same with my...
You use those for the updates.
Yeah, I do weekly updates. I set aside time to do them well. I spend at least an hour, 2 hours on them. I proofread it. I make sure that it's, I cover all the points. I make a list of things I want to talk about at each project milestone. So,
and I mean, these things that you're telling me this is all stuff that just goes along with running a good bit. I mean, this is business management 101. It's interesting that, the same things that apply to starting small businesses in the old world, let's say, still apply to Kickstarter. You still need a good connection with your customer.
Right, but I think a lot of guys that are working on this are the engineers and the geeks, and they don't necessarily have the business or people skills to run a successful PR campaign. They may be brilliant at programming and board layout, but on a bad day, they may fail the Turing test. And you need to have that balance in order to run a successful Kickstarter campaign.
Well, Terence, that is all the time that we have today. Having you on the show has been even better than that time Josh constructed a cake-making badger bot from T-Slots and AstroTurf. Thanks so much for being with us today.
Hey, thanks for having me on.
If you would like to send crates of T-Slots to EVDHQ, include hardware, batteries, and address it to Josh.
And if you'd like to send AstroTurf, I could use some, please address it to Adam. Engineer versus Designer appreciates those comments. If the thought of listening to the show causes your hand to inadvertently detach itself from your body and beat you in the face, head over to EngineerVsDesigner.com and let us know about those kind of problems.
Yeah, let us know.
See somebody about them.
Yeah. And if you want to see us LOL at nothing in particular, be sure to like us, +1 us, tweet us, or whatever else us. The social media has been correlated with overexcitement and typing LOL even when you're not actually laughing.
This show is edited by Simon Martin. Our theme music is by Ross Hartman.
We'll see you next week.
Goodbye. Goodbye. Rock.
A production of EVD Media.